Assalamualaikum warahmatullahi wabarakatuh. We are from Group G2, consists of Adinda Putri Rahmah, Belva Abrar Irawan, Ilya Marsya Rohila, Suryani Twentika Salsabila, Syafira Nurmala Sari, and Yasmin Awalia Sakirina would like to present our group work. The title is Isolation and Identification of Pinostrobin. The first slide will be presented by our friend Syafira. Time is yours.
Pinostrobin is a natural flavonoid found in various plants, well known for its wide range of pharmacological activities such as antioxidant, anti-inflammatory, anti-cancer, and neuroprotective properties. This is the pinostrobin structure. It consists of monohydroxyflavonone that is 2S-flavonone substituted by a hydroxy group at position 5 and a methoxy group at a position 7 respectively. It has a role as a plant metabolite and an antidote. It is a monohydroxyflavonone and a monomethoxyflavonone. It derives from a 2S-flavonone. Next. One of the plants that contain pinostrobin is temu kunci. It is one of Indonesian medicinal plants which contain essential oil and flavonoids, and it has interesting pharmacological activities such as antifungal, antibacterial, antioxidant, anti-inflammatory, and anti-cancer. The rhizome of B. pandurata contains bioactive compound flavonoids and chalcones. The pinostrobin show anti-inflammatory and analgesic activities through inhibition of CHOX2 enzyme, and also the pinosembrin and pinostrobin show cytotoxic effect in breast cancer and colon cancer cell line. Next slide will be presented by my friend.
Extraction method. Extraction is the process of taking the active substance from a compound by immersing the sample in suitable solvent. The most common extraction process that are conducted are maceration and sonication. Maceration is the process of soaking the dry material in a solvent for at least 1 to 3 days, while sonication has the same procedure but using an ultrasound-assisted extraction on a frequency 42 kHz. We use 10 grams of dry Simplicia temu kunci rhizome and we soak in 100 milliliters solvent. We cover it up with aluminium. We use a sonicator for 30 minutes in 40 degrees Celsius, and after that we do filtration and evaporate using vacuum helper to gain the thick extract. Next. The advantage of sonication method can remove the thermostable substance, which is the compound that can withstand heat and may complete in considerably less time, less than hour, and the process damaging consequence can be reduced. Sonication is based on the use of ultrasonic waves to generate cavitation. Cavitation produces energy, raise the temperature, raise the pressure, and it will cause damage to the material's outer surface, causing quicker mass transfer, faster extraction, and more demand to be generated. Next slide will be presented by Belva.
And then for choosing a solvent, we have to consideration several things, such as the principle of light dissolve light. For the first one is polar solvent may extract polar molecule, and then semipolar solvent may extract the semipolar or unpolar molecule, and for the nonpolar may extract the nonpolar molecule. And for the solvent that we use in this experiment is aryl acetate, which is semipolar, and pinostrobin belongs to the flavonoid, whereas flavonoid is a polar compound, so the aryl acetate can be used to extract the desired compound, that is pinostrobin. Next. And then for the physicochemical properties of the solvent associated with pinostrobin, as a semi-solvent, aryl acetate possesses physicochemical qualities such as a boiling point of 77 degrees of Celsius, a freezing point of minus 83.6 degrees Celsius, and solubility of 1 in 10 in water at 25 degrees Celsius. Lower temperatures make aryl acetate more soluble in water than higher temperatures. And it miscible with acetone, chloroform, dichloromethan, ethanol 95%, ether as well as most other organic liquids. Besides that, ethyl acetate has its own way of storing, so that whether the quality will remain good and not damaged. Because the moisture slowly decomposes ethyl acetate and can cause it to become acidic, and also the ethyl acetate should be kept in an airtight container away from light and at a temperature no higher than 30 degrees of Celsius. Next. And then for the next chapter, we have the fractionation method. Next. And for fractionation, there are mobile phase and stationary phase. And for fractionation has several steps. One of the steps is a mobile phase preparation. The mobile phase is a liquid or solution used to present the components, whereas the stationary phase is a fixed phase in a column of particles with small pores such as silica gel. And in this experiment, we utilize an hexane and ethyl acetate as mobile phases. And for the stationary phase, we use the silica gel 60. Then for the next slide will be presented by my friend Adinda. The time is yours.
Fraction method, the first one is the previous day extract was thick with a rotary evaporator. And for the second one 1 gram of the thick extract was weighed for fractionation using vacuum liquid chromatography. And number third is VLC was prepared and assembled according to the rules. The column tube was filled with 10 grams of silica gel 60, then compacted. Then the dry extract sample was placed on top of the silica gel on the VLC column and covered with filter paper. And the next one is 1 gram of extract was dried with the addition of 2 grams of silica gel and then stirred until dry. And the sixth is poured in the mobile phase with a gradient ratio of an hexane with ethyl acetate for each volume of 50 milliliter with a determined ratio, as you can see from the column. And number 7, collect each fraction obtained and dry it on a water bath. And the 8, perform TLC on a fraction obtained with standard Pinostrobin comparison. The stationary phase used was silica gel 60 GF 254, and the mobile phase was an hexane with ethyl acetate with the 4:1 ratio. And for the 9 is the fraction that had spot with the same RF value as the standard Pinostrobin was selected to be separated by preparative TLC. Next will be presented by next.
Next process is isolation. Next. Isolation can be done by many methods. The first one is CC or column chromatography, and then preparative HPLC, high pressure liquid chromatography, and then preparative TLC, and then HSCC or high speed counter current, and CPTLC, centrifugal preparative thin layer chromatography, and the last one is MPLC or medium pressure liquid chromatography. Next. There are 3 things that should be considered in the process of scraping compound in TLC. The first one is moisture on the TLC plate. The second one is make line between sample to make scraping easier. It's done to make sure that there is no contamination. And the last one is scrape off sample while it will be presented by Salsa.
Okay, there are several steps for isolation process. Step 1 is prepare a set of preparative TLC plate, making tools to make a preparative TLC plate. The step 2, on the top of the TLC plate and liner equipped with spacer plates, place 5 clean glass plates in a row. Step 3, prepare a jet applicator with a size setting of 0.5 millimeter silica thickness at the very end of the glass plate. Next. For the step 4 is dissolve 45 grams of silica with 90 milliliter of distilled water in an aluminum flask. Then shake until homogeneous. Then the next step, with one emulsion, pour it into the applicator gate and immediately spread it on the glass plate. Let it dry for about 1 hour. For the next step, the glass plates are activated in an oven at 115 degrees Celsius for about 4 hours. Next. For the step 7, form a band place the sample on the preparative TLC plates and then air dry. For step 8, put it in a TLC vessel that has been saturated with N-hexane ethyl acetate 4:1 ratio, mobile phase, and let it settle. The next step is scrap using a spatula to separate and suspected pinostrobin compounds. Next. Step 10, dissolve the scrapings using ethanol PA, then filter and evaporate on a water bath. And the last step is wait and identify the isolates obtained.
The last process is identification. There are two methods that can be done. The first one is the LC and the second one is LCMS or liquid chromatography mass spectrophotometry. There are three advantages of LCMS. It's fast, sensitive, and quite efficient. There are two types of the LCMS. The first one is indirect mass spectrometric analysis. It the analyte from the TLC plate, and the second one is direct mass spectrometric analysis. In this type, we don't need to scrap or extract and concentrate the the role of pinostrobin or standard pinostrobin is as a parameter or comparison of the result obtained whether pinostrobin or not, and the second one is to obtain the next.
Okay, for the identification process, first on the silica gel plate TLC60 GF 2055, plate size multiple 10 centimeter, place the isolate sample obtained. Then next to the sample holder, place the pinostrobin standard, then elute it using mobile phase and hexane ethyl acetate 4:1 ratio in a saturated TLC vessel. After elution, dry and read on a TLC densitometer scanner. Then in the isolation process, perform an analysis and then compare the characterization of the two.
Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.